So, this is podcast 3 of my Prologue is Amazing podcast. So, today I saw a lecture by David Warren. Now, he's not the one who invented the Warren abstract machine, but David Warren, who is Stony Brook, who's the creator of XSB Prologue, like he invented tabling in Prologue. And he was talking about the history of Prologue, and which has been going on for 50 years, and how, the progress in Prologue has been to make it more efficient while being declarative, right? So you can use Prologue, but sometimes it won't be efficient. And a lot of the research that goes on in Prologue is that how do you make it, how can you write it properly, like declaratively, while having it efficient. So tabling is like he invented is it's like you can just a lot of calls to the procedures are memorized, and so they run more efficiently. Like that basically comes down to it. And yeah, he was talking about other topics as well. And then I was watching the meta interpreters video by Marcus Triscott in Power of Prologue, and how that works. And I have seen some of that before, and I read some parts of the art of Prologue and craft of Prologue, and they were talking about it, how like you can change the execution strategy of Prologue from depth first to breadth first search just by because of the meta interpretation capabilities of Prologue, which is basically it's like the Prologue source code is just another set of facts in the database, and so you can manipulate them and change them around and get the effect you want. So I was doing that, and Marcus Triscott says the real capability of Prologue is the superpower is meta interpretation. So, for example, David Warren was talking a bit about it as well. So, for example, like let's say in Lisp you have macros, which they tell is very powerful, right? But the thing with Lisp is it's like the macros are forward, right? So you have to think about, well, I want that macro, and then it goes in and then it generates, right? In Prologue, what happens is that you can inspect whatever Prologue program you've written and change that around, right? So it's not you have to think about it beforehand. You can just take a Prologue program and start manipulating it around. You can't do that with Lisp, right? And so languages like Haskell, OCaml, were typed functional languages. So you can think of the types as like little languages, and you generate them, and you can see like Haskell and OCaml programs as basically manipulations of an abstract syntax tree. And so you refine that. You can see every function almost, or you could start viewing it as basically a series of compilers transforming something. Now, meta interpretation is that basically as well. Is basically about writing compilers or translators, right? Now, even with the Haskell and OCaml thing, you have to start thinking of it like you still have to kind of think of it as you don't just start off with whatever you've written. Like you have to write down and think about it, that you're transforming one structure to another and one structure to another, right? So it still doesn't do what Prologue's, natural translation abilities is where you just take a Prolog program and then start doing stuff from that. So it's still more powerful, Prolog is, than those other languages. Now, I'm sure these other people have things to say. Like I've seen a video by one of the Haskell creators. He's like, he was doing Prolog in the 80s or 90s or something, and then he switched to Haskell, and he was one of the authors of Haskell because he's like, he said something like, you know, with Prolog you have to know everything. Yeah, like the whole program, you always have to kind of think of it in your head, whereas which becomes difficult. Whereas in Haskell or Camel, like you're always thinking about a small bit. You're only considering a function and the data it transforms, right? So you don't have to keep, you don't have to, you like there's information hiding at a large scale. Like you hide all the information of the code and you only have to think about that one aspect. Whereas in Prolog, everything's open to you and you do have to consider everything. Now, that's one reason before I had switched to thinking in terms of those languages. And also I think this was last year or the year before, I went into all this kind of reading and listening to podcasts about category theory, which is what Haskell and OCaml is based around. And in mathematics itself, they originally thought of defined mathematics in terms of like relational stuff, like set theory. And then later in the mid 20th century, they started thinking about category theory. And, there's a project to redefine all of mathematics in terms of category theory, right? Because they kind of, I don't understand all this stuff, but they're like, it's easier and you kind of like you can relate areas of mathematics as being the same thing. If you can start defining their categories, then you can start realizing, oh, that's the same thing. So there's probably something to that, and there's much more Haskell and OCaml programmers than there is Prolog. So there must be something to that, right? So it's a bit weird, but why I'm going for Prolog. But I don't know, I might end up switching. Like, you never know. But right now I'm thinking in terms of Prolog. Now, a few things I wanted to do is have, how can I write apps for the web, for Android, and for iOS, like, iPhones, right? And I want it to be, I write it in Prolog and it's automatically translated to all three of them. So the way I was thinking is, it's like there's two ways, right? Either you have a little Prolog engine. So let's say on the web, a little JavaScript Prolog that's included. And then, everything queries the Prolog and then the interface is generated, right? Each page is generated by asking the Prolog what happens in, similar for Android, the mobile platforms. Another way would be, it's like the Prolog gets translated into, let's say, Java programs or JavaScript programs or the iOS, whatever it is, CTIC or whatever Apple uses. So, right, the whole Prolog program is translated. Now, it does seem like this would be not too complicated because Prolog meta-interpretation capabilities, like its introspection, like you could just look at your Prolog program and automatically extract it out to the different languages. And there is a Prolog I've seen before called Prolog Cafe, which is done by someone at Google, where Prolog is translated into Java source code, and then the Java source code can be run wherever Java is run, right? So direct translation. So somebody has done something like that that I've seen previously already. So yeah, that's another thing I was thinking about. Then I wanted to do things like interface to AI systems with Prolog, like maybe Google AI Studio or whatever the APIs available are, and start hacking around with that and see what happens, or maybe download the AI models to a computer. But I think maybe I'll just leave it on the internet, or maybe put it on my own desktop computer. But it's expensive to buy computers and the GPUs, whatever. Right, because what I wanted to do, so that kind of works in English, right? So my idea is that, even if when you have AI tools, you still want something where you can specify your stuff, and then English language is generated, and you can have all this like combinatorial stuff, like, the outer join, and then it goes to the AI, and the AI generates what you're looking for. Like, let's say you could specify in Prolog, it writes English text of that specification, that goes to the AI. The AI generates the code, like in Java or C or whatever, and writes out programs, or it generates diagrams or animations or whatever you need, right? Or like, you could, like, let's say you want to write a poem or a song, you have it done in this, and then it goes to all these kind of requirements are output, and then goes to the AI, and the AI will generate a song according to those requirements. Okay, rather than you sitting down and typing in English, because English is ambiguous. So that's a thing. And so yeah, I will try those out, and maybe that's a possibility that if that's successful, then try to market that and make myself known, or try to generate something for myself from that, and hopefully that gets me the fame and riches. But definitely there's a lot of, and there's a lot of possibilities, I believe, still left in programming, especially if you're using something like Prolog. Now, I also wanted to do music generation, although maybe I'll just leave it to AI music generation, and but I was thinking of interfacing Prolog to, let's say, C Sound or whatever the music programming systems are, like Digital Music. And right, so like also to diagramming systems, right? Like I want to be able to present things on HTML with HTML CSS. I want to be able to present things on in a 3D system like Povray or maybe Blender as well. I want to be able to present things in music like C Sound. I want to be able to present things as diagrams. So there's various latex packages for diagramming. Like I can't remember their names right now, but that's a thing, or Dia, and right, so I have interfaces to them, so I can do those. And yeah, so I think like once you get it, and then also I will post all these as open source on the Prolog community servers, and maybe like that will lead to opportunities for me. And then on top of that, so once you have those, you can start to do stuff with computers, right? In one sense, there's like these kind of interfaces to conventional computer software, like diagrams and 3D scene descriptions and whatever. And then there's interfaces. So the AI systems generate things like text and video and pictures. But to control both of them, and then you have the core to control both of them. You do all your logic in literally a logic programming language, and all the features that gives you will, I believe, will lead to massive, to give a competitive edge to whoever is doing that, rather than directly writing in those things. So yeah, and then I was also thinking of, maybe like a fun project would be to use Prolog to automatically read, like documentation of, let's say, Povray or HTML, CSS, or Blender documentation. Automatically read it, automatically build all the interfaces, right? And then even give you a description to use, right? So rather than going in, hand coding, reading the documentation, putting it in Prolog, have Prolog read all the documentation and do all that itself, right? So that would be a fun project to do. Maybe, I don't know if I'm capable, but or have enough time, but it would be so, and that would maybe be something, and I could talk about that and give talks on that, and be known for doing that.